Hi, my name is Wei Wei, and today I'll be presenting question 4 of Risk Theory Computer-Based Test. So for question 4, with the given information, we are required to find the probability that number of claims will be at least 20 and the expected of nm squared given that nm is larger than 0. So the given information is the probability of nm equals to 0 is m, and the probability of nm equals to n equals to k times n plus 1 times 1 over a plus 1 to the power of a times a over a plus 1 to the power of n, whereby n equals to 1, 2, 3, and so on. And the expected of nm cubed, which is the third moment, equals to 226.125. Since the question didn't mention the kind of distribution, so I start off by identifying the distribution. So I use probability of nm equals to n over probability of nm equals to n minus 1 equals to a plus b over n, where I can use a and b to determine the kind of distribution. So this equals to k times n plus 1 times 1 over a plus 1 to the power of a times a over a plus 1 to the power of n divided by k times n times 1 over a plus 1 to the power of a times a over a plus 1 to the power of n minus 1. So in this case, k and 1 over a plus 1 to the power of a can be cancelled out, and we get n plus 1 times a over a plus 1 divided by n. So calculating will get us a over a plus 1 plus a over a plus 1 divided by n. So this shows us that the a is a over a plus 1 and the b is also a over a plus 1. Since a and b are both positive, so this is a negative binomial distribution. For negative binomial distribution in AB0 class, a equals to beta over 1 plus beta. So by substituting the a from this part in here, we get a over a plus 1 equals to beta over 1 plus beta, which means a equals to beta. And for b equals to r minus 1 times beta over 1 plus beta for AB0 class. So substituting b from here, we get a over a plus 1 equals to r minus 1 times beta over 1 plus beta. So here we get r equals to 2. By comparing the PDF of the AB0 class and 0 modified negative binomial distribution, we can see that the probability of n equals to n is actually very similar. So for AB0 class, probability of n equals to n is r times r plus 1 times until r plus n minus 1 divided by n factorial times 1 over beta plus 1 to the power of r times beta over beta plus 1 to the power of n. So I let beta equals to a from this part, and r equals to a, n equals to 2. So then probability of n equals to n is 2 times 2 plus 1 times until 2 plus n minus 1 divided by n factorial times 1 over a plus 1 to the power of a times a over a plus 1 to the power of n. So then we get 6 times n plus 1 divided by n factorial times 1 over a plus 1 to the power of a times a over a plus 1 to the power of n. So by comparing it with the equation from the question, we see that it is practically the same. So this proves that r equals to a and a also equals to 2. After solving for a equals to 2, we can see we still have two unknown variables, which are m and k. So we can use the given information provided by the question to solve for the m and k by using the solver function in Excel. So I used two different equations to solve for m and k, and the first equation will be the third moment of nm. It is given that the third moment equals to 226.125, and First, I create 3 columns, which is the first column is the values of n. The second column is n cubed, which is this value raised to the power of 3. And the third column is the probability of nm equals to n. So from the question, probability of nm equals to 0 is m. So for this one, I let it equal to the value of m, which is in this cell right here. But for the following probabilities, we can follow this equation. So it is equal to k, which is in this cell of k14, times n plus 1 times 1 over a plus 1 to the power of a, which is this cell right here, times a over a plus 1 to the power of n. So then we drag down the formula to the following cells, and then we will get the probability of nm for the corresponding values of n. So then the third moment of nm will be the sum product of n cubed column and the probability of nm equals to n column, since the expected of nm cubed is n cubed times the probability of nm equals to n. And then the second equation will be the total probability, which is this column, will be equal to 1. So the sum of the probability of nm equals to 0 to n equals to 100 will be 1. So I let the sum of P4 to P104 equal to 1. So by opening up the solver function, we set the objective to K9, which is the equation for the third moment of nm, and it is equal to the value of 226.125. And the changing variable cells will be K13 and K14, which are the cells for m and k. And the subject to the constraints is the second equation, which is K10, the total probability equation, equals to 1, which is in cell L10. And then we click solve. I get the values of 0.250001 for m and 0.84375 for k. And this should also help us to calculate the probability for each values of n. Probability that the number of planes will be at least 20. It is the probability that nm is larger or equal to 20. So this equals to 1 minus the probability of nm less than 20. So to get this value, it is equal to 1 minus the sum of probability of nm equals to 0 until probability of nm equals to 19, which is until the cell P23 here. So we get the value of 0.001944 for this probability. To get the expected value of nm squared, given that nm is larger than 0, we get a separate column for n squared, which is the value of n raised to the power of 2, and then also the probability of n intersect n larger than 0, which is the probability of nm equals to n divided by 1 minus probability of nm equals to 0. So for n equals to 1, which is the probability of nm equals to 1 divided by 1 minus probability of nm equals to 0. And this goes for the following values of n. And to get the expected value, it is the expected of nm squared, which intersects with the probability of n larger than 0, divided by the probability of nm larger than 0. So in this case, for when n equals to 1, it is 1 squared, which is in cell Q5, times probability that in n intersects with n larger than 0 in cell R5, divided by the probability of nm is larger than 0, which is 1 minus probability of nm equals to 0 in cell P4. So we log on the cell P4 because the probability of nm equals to 0 is constant. So this is also the same for the following values of n. So in the end, to get the expected value of nm squared given that nm is larger than 0, we sum all the values in this column to get 42.00011. And that is all for question 4. Thank you.